Carbon Glacier, a massive river of ice, flows down almost the whole length of Mount Rainier. The Carbon Glacier stretches over 5 miles down to a terminus, or end elevation, of 3,500 feet. This makes it both the longest and lowest terminus glacier in the contiguous United States. It is also the deepest glacier in the country, with ice almost 700 feet thick in places.
So as spectacular as it is, Carbon Glacier is just a pocket-sized descendant of the glacier that was here for hundreds of thousands of years on the northwest side of Mount Rainier. In the same space where you're standing and breathing right now, a large glacier existed to a thickness of about 2,500 feet or more. The glacier extended as far down valley as the metal bridge that you crossed on the way here to the ranger station. So compared to those Ice Age glaciers, Carbon Glacier today might seem pretty small. But in fact, it's been relatively robust historically and has been one of the healthiest glaciers on Mount Rainier. Carbon Glacier is rather unique because it is separated into two pieces. Its accumulation area exists near the summit, and then there is a 4,000-foot cliff called Willis Wall that separates it from the lower part of the glacier, which exists in a valley, and then the terminus extends down to around 3,500 feet, which is the lowest elevation of any glacier terminus in the contiguous United States. Snow and ice from the accumulation area near the summit of Mount Rainier continues to feed the glacier below via many snow avalanches and ice calving events off the Willis Wall. And we also have a lot of rock falling from it as well, and that gets incorporated within the snow. The snow metamorphoses to ice, becomes part of the glacier, and the entire mass of snow, ice, and rock moves down valley as the glacier. At low elevations, the ice melts and the rock remains behind and covers the surface of the glacier with this covering which insulates it from solar radiation.
From early visitors to scientists alike, Carbon Glacier has inspired awe. Bailey Willis was the first geologist to explore the area. The cliffs at the head of the Carbon Glacier are still known as Willis Wall. Bailey Willis, however, did not find the Carbon Glacier very attractive. On his first survey of the glacier in 1881, he notes,
"This first sight is a disappointment. The glacier is a very dirty one. The face is about 300 feet long and 30 to 40 feet high. It entirely fills the space between two low cliffs of polished gray rock. Throughout the mass, the snows of successive winters are interstratified with the summer's accumulation of earth and rock. From a dark cavern whose depths have none of the intense blue color so beautiful in crevasses and clear ice, Carbon River pours out, a muddy torrent. The eye willingly passes over this dirty mass to the gleaming northeast spur of the mountain, where the sunlight lingers after the chill night wind has begun to blow from the ice fields." Bailey Willis, Explorations on the Northern Slopes, 1881 to 1883.
The Carbon Glacier's low elevation made it relatively easy to reach for visitors wishing to experience a glacier. The Carbon Glacier has also been a popular route for attempting the summit of Mount Rainier. However, the characteristics that make Carbon Glacier so unique also make it extremely dangerous.
The climbing routes that use the Carbon Glacier as part of their access to the route really is limited to one route that people normally do, which is Liberty Ridge. It's one of the 50 classic climbs in North America. And rightly so, it's one of the more unique routes on Mount Rainier because it exists on a small ridge between the Willis Wall and the Liberty Wall, which are two unique features on Mount Rainier. The route is very, very exposed. It's consistently 45 to 55, maybe even 60 degrees in some places. So with each step moving forward, you're actually moving more up than you are across. And after you get up 4,000 to 5,000 feet, you're actually 1 mile above the terrain below you. So, and even with that, sometimes the footing is so tenuous that you're only getting your front 2 points of your crampons and your 2 tools of your ice axe into the snow and ice as you climb. So being a mile up, having only a few pieces of steel into the surfaces that you're climbing up can be very exhilarating, and that attracts a lot of people. And of course that's the downfall of many of the folks. Because it's such a committing route and people don't like to descend it, people often get stuck on the route ascending into worsening weather because they don't see descending as an option. And that's one of the fatal pitfalls of that route, is people don't allow enough time, and that's been the downfall of many people.
Dangerous and intriguing, Carbon Glacier is one of the marvels of Mount Rainier. This massive ice flow molds the landscape even as the mountain shapes the glacier in turn. It is the source of the mighty Carbon River, providing water for many ecosystems. However, despite some unique factors such as rock debris insulating the glacier, the Carbon Glacier is not immune to changing climate conditions.
We're in the upper part of the Carbon River Valley, which is in the northwestern part of the park. And we're actually in view, I think over my shoulder you can see the lower part of the Carbon Glacier beneath Mount Rainier. The Carbon Glacier is actually one of the thickest glacier on Mount Rainier that has about 25 glaciers. And it has, there's more glacier ice on Mount Rainier than all the other Cascade volcanoes combined. And the Carbon Glacier starts near the summit, so even under the most dire climate scenarios, it's not expected to disappear. But it's definitely being affected by the climate. And what's been happening recently, though, it's actually been happening for quite a while, but it's been accelerated recently, is the glaciers are melting quite quickly. Sort of on average in the 20th century, the glaciers lost maybe 25% of their volume. But the park has been measuring the glaciers, they call it a mass balance study, measuring the health of the glaciers, are they getting bigger or smaller. But unlike the glaciers on the other side of the park, instead of getting shorter, this glacier is more or less deflating. So it's not responding as dramatically as the glaciers on the south side of the park. And that's because they get a lot of sun, so they're just much more attuned to the climate and much more sensitive. Yeah. But essentially, all the glaciers are melting on Mount Rainier, and as they do so, they're putting a prodigious amount of sediment into the rivers. Glaciers have big piles of rubble on the side. It's called the lateral moraine. And what has happened is this one has shrunk back from that. And it's the only glacier in the park where it's having massive landslides that are coming down between the glacier and this moraine. And these landslides are depositing in this whole area where we are. And it's hard to envision just from these pictures, but this was a forest where we're standing. It was an old-growth forest, centuries old, in 2009. Since then, the river has completely shifted through here, and we're getting wholesale changes of the Carbon River, where the main channel is just shifting and killing forests that have been around for centuries. This signals a very big change for the river. Yeah, I sort of joke through the park that, you know, nature bats last. But that doesn't mean that we're hopeless and just say things are chaotic and we can't predict anything. We are working very hard this summer, and we have some very bright master students working on it, where we're looking where these sediment accumulations are. And since they are dynamic and moving, we're trying to help guide how much money they put into repairing the trail. So if you see one of these sediment accumulations that's forcing the water to the valley sides where it's hitting the road or the trail, if it's right there now, it's sort of foolish to spend your money on it now. But if you can actually predict using some data that bulge will move in the future, you have a much higher chance of success. And since budgets are always a little bit limited, we feel if we can use science to help guide the timing and the nature of their repairs, you know, we can just spend the money in the most wise sense and provide the most access to the public.
Like all glaciers in Mount Rainier National Park, the Carbon Glacier is a dynamic force shaping the landscape of the mountain. It is a source of life-giving water, but also holds the potential for terrible devastation. It has been a draw for explorers and visitors for over a century. Mount Rainier National Park continually works to understand the Carbon Glacier so that it will be there to challenge and amaze us into the next century. This makes it both the longest and lowest terminus glacier in the contiguous United States. It is also the deepest glacier in the country, with ice almost 700 feet thick in places.
So as spectacular as it is, Carbon Glacier is just a pocket-sized descendant of the glacier that was here for hundreds of thousands of years on the northwest side of Mount Rainier. In the same space where you're standing and breathing right now, a large glacier existed to a thickness of about 2,500 feet or more. The glacier extended as far down valley as the metal bridge that you crossed on the way here to the ranger station. So compared to those Ice Age glaciers, Carbon Glacier today might seem pretty small. But in fact, it's been relatively robust historically and has been one of the healthiest glaciers on Mount Rainier. Carbon Glacier is rather unique because it is
Carbon Glacier, a massive river of ice, flows down almost the whole length of Mount Rainier. The Carbon Glacier stretches over 5 miles down to a terminus or end elevation of 3,500